Hi there, this is the magnificent Mr. Jansen, and today we're going to be looking at some of the factoring shortcuts. I'm going to reveal some secrets of the universe to you here. So taking a look at these first couple, we already know how to do this shortcut, but I'm going to review it because it helps when we look at things that don't have a coefficient 1. So remember that when we have a leading coefficient of 1, when we do this by factoring this by grouping, we build a bridge that gives us a negative 12. The two numbers that multiply together to give us a negative 12 but add together to give us the middle term, which is the positive 1, are going to be a positive 4 and a negative 3. So by grouping, we split up the middle term, and we end up doing this as x squared plus 4x minus 3x minus 12. And then we group the first two terms together, group the second two terms together. Out of the first two terms, we can factor out an x, which leaves me with an x plus 4. Out of the second two terms, I can factor out a negative 3, which leaves me with an x plus 4. And then from here, this is where the magic happens. I've got an x plus 4 and an x plus 4. Those two factors are the same, which means my two factors are the x plus 4. And if I were to factor out that entire chunk, it would leave me with an x and a minus 3. So my other factor is the x minus 3. And through doing a couple of these, we can very quickly find out that there's a big shortcut we can take here. That when I build the bridge, when I do the 1 times the negative 12, and it gives me the negative 12, the two numbers that multiply together to give me a negative 12 but add together to give me the positive 1 are the 4 and the negative 3. And those two numbers are actually the numbers from my binomial when I actually finish factoring this thing. So I can go right to the answer and say it's going to be an x plus 4 because it was a positive 4 and an x minus 3 because it was a negative 3. Okay, so that's our factoring shortcut when the coefficient is 1. It's pretty simple. We just use those two magic numbers from the bridge, and that gives us our two factors. For examples when the leading coefficient is something other than 1, so it's not 1, in the first example here I have a 2. Again, by grouping, we would build a bridge. The 2 times the negative 3 gives us a negative 6. The two numbers that multiply together to give us a negative 6 but add together to give us a positive 1 are going to be a positive 3 and a negative 2. So when I do this by grouping, again, I would split up the middle term. So I'd write this as a 2x squared plus 3x minus 2x minus 3. I split that middle term up into two terms, and then I do my factoring by grouping. Group the first two terms together, group the second two terms together. Out of the first two terms, I can factor out an x, which leaves me with a 2x plus 3. Out of the second two terms, I can factor out a negative 1, which is going to leave me with a positive 2x plus 3. And now when I look at this, this is where the magic happens. The 2x plus 3s they have in common, so one of my factors is the 2x plus 3. If I were to factor that out of there, it would leave me with the x and the minus 1, so my other factor is the x minus 1. And that's how we factor it by grouping. But now let's look at a little bit of a shortcut. What I'm going to do in this shortcut is I'm going to do something that's seemingly incorrect, but then I'm going to compensate for what I did incorrectly and make my answer right again. Okay, so I'm going to do something that seems incorrect, but I'm going to compensate for it by doing something that makes the incorrect step correct again. Okay, so I start off the same way. I'm going to build a bridge. So I build a bridge, it gives me the negative 6. And now two numbers that multiply together to give me a negative 6, but add together to give me the positive 1. Are the 3 and the negative 2. And from here, here's where I'm going to do this thing that seems incorrect. I'm going to write this almost as if I was doing my previous shortcut. I'm going to write this as a 2x plus 3 and a 2x minus 2. And obviously that's incorrect. Okay, that's not right because when I FOIL this back out, the 2x times 2x will give me a 4x squared and not a 2x squared. So what I've essentially done is I've multiplied by a 2 when I shouldn't have. So to undo the mistake that I've made, to undo multiplying by that 2, I'm going to divide this whole thing by 2. Okay? And what happens here, essentially, it's like what I did over here with an added twist. If I take my solution from over here, the 2x plus 3 and the x minus 1, I could multiply this. This is like over 1. I'm going to multiply this by a form of 1, almost like getting a common denominator. If I multiply by 2 over 2, essentially what that's going to give me is I can multiply that. I can leave that 2 on the outside. I'm going to distribute that 2 into this second binomial, thus giving me a 2x plus 3 and a 2x minus 2. And so now we can see that the two things I have written here, grab another color here, the thing I have written here and the thing I have written down here are essentially the same thing now that I've gotten a common denominator. All right? But now working backwards from this, really, here's the 2. Here's the extra 2 that I had in here. And I'm just going to divide that out. So when I look at this, that second binomial is divisible by the 2. So I'm going to cancel the 2's from all of these binomials, which when I do that, it's going to leave me with a 1 here. So my two factors are the 2x plus 3. And then that second binomial, after I divide it by the 2, is going to leave me with an x minus 1. Okay? So in summary, when I do this shortcut, I do something that's seemingly wrong, but I compensate for it by dividing by that 2. All right? I multiplied by an extra 2, so I divide by an extra 2, which essentially means I'm multiplying by 2 over 2, which doesn't change anything. I'm multiplying by a form of 1. And that's my answer. So real quickly, doing a couple of these, just to show you how this works. For this one, again, I'm going to use the shortcut. I'm going to build a bridge. So I build a bridge. That gives me a negative 10. The two numbers that multiply together to give me a negative 10, but add together to give me the positive 3, are a 5 and a negative 2. So from here, I'm going to split this into a 5x plus 5, and I'm going to do a 5x minus 2. And the thing that I've essentially done wrong here is I've multiplied by too many 5's, so I have to compensate for that by dividing by a 5. So now instead of multiplying by too many 5's, I've really multiplied by 1, 5 over 5. And when I look at the two binomials, I can't divide the 5 out of the second binomial. I have to divide it out of the first binomial. Okay? When I divide this first binomial by 5, it cancels and leaves me with a 1x plus 1 over 1. So my two factors here are the x plus 1 and the 5x minus 2. All right? And mathematically, again, that works because I'm essentially multiplying by a 1 over 1 and then canceling out where I can to get rid of that denominator. For the second one, if I try another one more here, I'm going to build a bridge. So 4 times a 3, that's going to give me a 12. Two numbers that multiply together to give me a 12, but add together to give me an 8 are going to be a 6 and a 2. So now I'm going to do something that's seemingly incorrect. I'm going to do a 4x plus 6 and a 4x plus 2. And so what I've done is I've multiplied by too many 4's, so I have to divide by a 4. So now I've essentially multiplied by 4 over 4. And the issue I run into here is when I look at each of these binomials, neither one of them is divisible by 4. The first binomial is not divisible by 4, and neither is the second, but remember that 4 is the same thing as 2 times 2. So if I rewrite the 4 as a 2 times 2, now when I look to cancel this out, I can cancel this first 2 with the first binomial, which gives me a 2, a 2x plus 3, and that cancels with the first 2. The second 2 is going to cancel with the other binomial, leaving me with a 2x plus a 1. So essentially what I do here is I have to divide off that 4, and I have to completely divide it off. Sometimes I just have to use part of it with the first binomial and part of it with the second binomial. And what this leaves me with for my answer is going to be a 2x plus 3 and a 2x plus 1. And that's it. So again, using this factoring shortcut, we do something that seems wrong, but we make it right by dividing by the thing we've accidentally multiplied by. Okay? Hope this was helpful, and good luck in using. Please use responsibly.